There's something wrong with our universe, a deep, fundamental anomaly that's written into the very fabric of space-time. And we can only see it when we look at the oldest light there is. It's a cosmic cold case, and the prime suspect? Well, it might just change everything we think we know.
So the question is pretty simple, but the answer could rewrite our entire cosmic story. What left this giant bruise on our universe?
So what you're looking at here is basically the universe's baby picture. It's called the cosmic microwave background, the afterglow from the Big Bang. And for the most part, it's almost perfectly uniform. Almost. See that massive blue patch? That's the cold spot. It's a region of space 1.8 billion light years across that is just way, way colder than it has any right to be. And that's the real problem, isn't it? Standard physics, our best model of how everything works, just can't fully explain this thing. The leading theory is that it's a super void, a huge empty patch of space with no galaxies. But that only explains maybe 20% of the coldness. The other 80%? It's a total mystery. So it's pretty clear, we need a new suspect. And that brings us to a really radical idea. What if the Big Bang wasn't a beginning at all? What if it was an impact? This is called the ekpyrotic universe theory. It suggests that our universe is a kind of membrane or a brain that exists in a higher dimension. And our Big Bang? Well, that was the moment our brain collided with another one. Let's just break that down for a second. Imagine two gigantic sheets just floating in a higher dimension. Then 13.8 billion years ago, they touch. That collision is what created all the energy and all the matter in our universe. And right now, they're slowly moving apart from each other. Now, here's what's so cool about this. It's not just a wild idea for the sake of being wild. It's that this one single event, a collision, seems to just elegantly solve some of the biggest, most stubborn problems in all of cosmology. So take dark energy, for example. The standard model says there's some mysterious internal pressure that's making our universe expand faster and faster. But in the collision model, the mystery kind of disappears. The dark energy we're feeling, it's just the gravitational pull of that other universe, tugging on us as we move apart. It's not a push from within, it's a pull from without. And it also has this brilliant solution to the flatness problem. See, we've observed that our universe is perfectly flat, which statistically should be basically impossible. The standard theory invents the super-fast inflation phase to explain it, but the collision theory has a much more intuitive answer. Think about it. If you smash two spherical snowballs together, the point where they hit becomes a flat disk. The sheer force of that cosmic collision would have naturally ironed out all the curves. The theory's power doesn't stop there. It tackles another huge puzzle, the hierarchy problem. In simple terms, why is gravity so much weaker than all the other fundamental forces? I mean, a tiny magnet can pick up a paperclip, completely defeating the gravitational pull of the entire planet Earth. Why? And the collision theory offers this beautiful answer. In this model, particles like electrons and photons, they're stuck to our brain, our universe. But gravity, it's made of what they call closed strings, so it's free to leak between the two universes. So gravity feels weak to us because we're only experiencing a tiny piece of its total strength. Most of it is in the other room, that higher dimension connecting our two brains. Okay, a theory that solves this many problems at once is pretty compelling. But any good detective needs evidence. And the smoking gun, well, it might be hiding in plain sight, right back where we started, in that cold spot. So when we look at the cosmic microwave background, it's not just one anomaly. There are several that this collision theory seems to explain perfectly. First, you've got the cold spot itself, with that 80% of unexplained coldness. It looks exactly like the bruise you'd expect from an impact. Second, our universe is lopsided. One hemisphere is hotter and noisier than the other, which suggests a glancing blow, not a perfectly uniform explosion. And finally, physicists have even found these faint concentric circles, which could be gravitational echoes from a universe that existed before ours, a key part of this whole cyclical idea. But the most shocking piece of evidence, the one that's really hard to ignore, comes when we actually measure the geometry of the cold spot itself. An analysis found that the geometry there is just wrong. Light passing through the cold spot bends 30% less than it should, even after you account for the void. This suggests it's not just that something is missing in that space. It's like the very fabric of space-time itself is torn or incomplete.
And this leads us to the most mind-bending idea of all. What if the cold spot isn't a place, but an absence of possibility itself?
You know, in quantum mechanics, waves can add up and get stronger, right? But they can also cancel each other out completely. It's called destructive interference. Two possibilities can combine to create zero possibility, nothing. So here's the crucial point. What if the cold spot is a region where the universe tried to exist in two different ways at the same time? And those two competing timelines, they collided and annihilated each other, leaving behind not just empty space, but a fundamental scar in reality, where existence itself just failed to load. And this all builds to one single coherent picture, the holographic ekpyrotic universe. The theory suggests we live in a universe that acts like a particle. Our beginning was a collision. The cold spot is the bruise from that impact. And the reason gravity is so weak is because it's the force connecting us to that other reality that we can't even see. I mean, this is a theory that just fits the data in ways the standard model can't seem to. It turns a cosmic glitch into a clue, and it points to a reality that's so much grander, older, and stranger than we imagined. And it leaves us with one final, incredible question. Was our Big Bang a singular, one-time event? Or was it just one bounce in an endless cycle of cosmic birth, death, and rebirth?